Okay, so this is going to be part 1 of the lesson on permutations, and this is section 11.2. Alright, so again, this is going to be part 1 of that lesson. Now before we go on to the idea of permutations and factorials and all that, let's kind of review something from a previous lesson. So go ahead and take out that handout. This is in Canvas, and let me go ahead and make that a little bit larger so you can see it. Okay, so all right, so remember the fundamental counting principle. This, in some books, they'll call it the fundamental counting theorem. So in the previous section, we called it the fundamental counting principle. Remember that? Okay, so it says this: if an event has m possible outcomes, and another independent event has n possible outcomes, then there are, and remember we multiplied, we'd say, all right, so we want to know how many possible outcomes there are, we multiplied those. So we'd say m times n, and that would be the number of possible outcomes. Okay, and so we also extended it to more than 2. We had examples where we had three events. So event 1 had m possible outcomes, event 2 had n, event 3 had p ways, and so to get the number of ways, we multiplied m, n, and p together. All right, so for example, for a college interview, Robert has to choose what to wear from the following. So he has 4 slacks, he has 3 shirts, 2 shoes, and 5 ties. Do you remember how to find the number of possible outfits? So remember we did this. So the number of slacks is 4, the number of shirts is 3, the number of shoes is 2, and the number of ties is 5, right? So there are 4 choices to choose in terms of a slack, and he has 3 choices in terms of a shirt, and he has 2 choices in terms of his shoes, and then 5 ties. And so together, when you multiply that, that would give you the number of outcomes. Now remember what we did when we started that, we used that tree diagram. Remember that? So we had 4 choices for the slack, and then from there we had those branches. We had branches, and then we would count. We counted how many there were altogether. So in this particular example, though, there would be, let's see, 5 times 2 is 10, 4 times 3 is 12, and then 12 times 10 is 120. Is that what you get using a calculator? Use a calculator. Remember, multiplication is commutative, so the order did not matter. So the next example says the standard configuration for a Texas license plate is 1 letter. So let's look at this. So the first one is 1 letter. All right, letter, followed by two digits. So these are digits, and then followed by 3 letters. Okay, so letter, letter, letter. All right, and so it says this: how many different license plates are possible if the letters and digits can be repeated? All right, so remember there are 26 letters in the alphabet, and they can repeat it, so this would be 26. Y'all agree? All these would be 26 because all these represent letters. And then for the digits, remember our digits are 0, 1, 2, all the way to 9, so that's 10 of them. So each one of those is 10 because I can repeat. So if I multiply that, so what we did was he said 26 times 10 times 10 times 26 times 26 times 26, and I got this big number. So let me just go ahead and write it out. All right, so 45 million, right? A little more than almost 46 million. Then it says how many different license plates are possible if letters and digits cannot be repeated. So do you think that this will be smaller or larger than this? It should be smaller because these numbers will be smaller. All right, so that will be for this one. All right, now for this one, remember what we did. So again, letter, digit, digit, letter, letter, letter. So in the first one, we had 26 to choose from. All right, so let's suppose I picked A here. Then when I get to this one, do I still have 26 letters? No. You have how many? 25. When I get to this one, how many do I have to choose from? 24, because I used up 2 of them. And then over here, how many do I have? 23, because remember it says digits and letters cannot be repeated. So then if I go to the digit part, how many do I have to choose from the first one? 10. All right, now if I pick one, how many are left? 9. So therefore, I'll multiply those using a fundamental counting principle. And so I get 26 times 10 times 9 times 25 times 24 times 23, and I get this. Oops, I need one more zero. All right, so I get that. Oops, I am messing this up, aren't I? So it's 32,292,000 possibilities. Okay? All right, so that was that one. Now, let's look at this example. Let me go and do that here. All right, so listen carefully to this part. Okay, suppose, all right, in how many, I'm going to write this example down. In how many different orders can 3 runners finish a race if no ties are allowed? Okay, so how many different orders can 3 runners finish a race if no ties are allowed? Okay, so let's call the runners A, B, and C. So let's say the runners are A, B, and C. Okay, so those are my runners. Do y'all agree that A can come in first, B can come in second, C can come in third, right? Okay. What's another possibility? A can come in first, and then what could happen? C could come in second, and B could come in third. Y'all agree? Okay. What else could happen? All right, well, B could come in first. Let me go ahead and kind of do this. All right. So what else could happen is the order could be B could be first, then A could be second, C could be third, right? Okay, then B could be first, C could be second, and A could be third. Y'all agree? All right. And then what else could happen? Well, C could be first, A could be second, and B could be third. And then C could be first, B could be second, A could be third. Y'all agree with that? All right, so at this point, it looks like I have how many different orders? 1, 2, 3, 4, 5, 6. Okay, 6 different orders. Okay, so what I want to do though is, so y'all agree that the answer to this question is 6. So there are 6 different orders. Okay, 6 different orders. I'm going to use a different word in a little while. But I want you to notice I could have applied the counting principle here. I could have applied the counting principle here. And so here's my thinking. So I have that this can be thought of in 3 events. So the first event is that someone finishes first, right? So how many possibilities are there for someone to finish first? Well, it could be A, it could be B, or it could be C. So what is that? How many is there? 3, right? Okay, so let's say A finished first. How many are left? 2. So how many people can finish second? How many choices are there? 2. So I can do a 2 here. And then finally, how many are left for the last one? 1. So if I multiply that, I get 3 times 2 times 1 is 6. Okay? All right, now listen carefully to this. Listen very carefully. All right, do you see how I placed these runners in an order? Okay, A, B, C, A, C, B, B, A, C, and so on. Those are called, instead of saying 6 different orders, we can say 6 permutations. All right, so there's the new word, permutations. All right, so let's talk about what a permutation is. All right, so a permutation of a set of distinct objects. All right, so these were distinct. person A, person B, and person C are not the same person, right? They're different people. Okay. So a permutation of a set of distinct objects is an ordering of the objects in a row. Is an ordering of the objects in a row. Okay, so that's one idea. All right, so a permutation of a set of distinct objects is an ordering of the objects in a row. Okay, now let's look at this one. All right, so permutations or orderings of n objects. Okay, permutations or ordering of n objects. So when we talk about permutations, the order matters. So always remember that permutation. That's what most people remember of permutations. But permutations, the order matters. Okay. So that's easy to see because when we did this problem right here, whoever came in first, second, third, right? The order mattered. So the order in which I placed people was determined by how they finished. So this was the first place, second place, third place. The order mattered. Do y'all see that ABC is not the same as ACB? That's what that also means, okay? So listen carefully. Is the order ABC the same as the order ACB? Yes or no? The answer is no. Because A, B, C, this is first, second, third. This is first, second, third, right? So second here is B, second here is C. So that order is not the same as that order, okay? So order matters. Order matters. This order is different than this order. So these are 6 different permutations. The order in which you wrote them did matter. Okay. Let's look at this example again. So sitting in a row. So Jack, Bob, and Alice is a different permutation of Alice, Jack, and Bob, right? Okay, we just talked about that. So look. So if I have Jack, Bob, and Alice, and let's say they're in this row. So they're sitting in this row. Is that the same order as Alice, Jack, and Bob? That's a different order, right? That's a different order. So if you enter a room, if Jack comes in first, Bob comes in second, Alice comes in third, is that the same order as Alice coming in first, Jack second, Bob third? No, those are different orders. Okay, so that will be permutations. Order matters. All right, so how many permutations can we make if 3 students, Jack, Bob, and Alice, are sitting in the same row? Well, that's the same as the previous example, isn't it? So the number of permutations, they want us to list them. So I'm just going to go ahead and say Jack, Bob, Alice, that's one. Jack, Alice, Bob, that's another one. So I'm going to put Jack first. Then I'm going to put Bob first. So we have Bob, Jack, Alice, Bob, Alice, Jack. Then I'm going to put Alice first. Alice, Jack, Bob, and then Alice, Bob, Jack. That should be 6. 1, 2, 3, 4, 5, 6. So there are 6 permutations. So if you use the fundamental counting principle, what that means is this. How many choices are there for Bob to be in that first chair? Well, 3, right? I'm sorry, for either one of them to be in that first chair. Excuse me, I didn't mean Bob, but any person, 3. Let's say it's Bob, though. How many people are left? 2. So I have a choice of 2 people for the next, and then finally the first, and 3 times 2 times 1 is 6. Okay? All right, what about the letters A, B, C, D? Without listing them, what do you think it is? All right, so how many are there? There are 4, right? So I'm trying to find out how many permutations there are, meaning if I put them in different order, how many orders would there be? So there'll be 4. What's the next one? Times 3 times what? 2 times 1. And so 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. So there are 24 permutations. Okay? All right, now that brings us to another concept. You may or may not remember this, but that's called factorial. Factorial, and your calculator has factorial on here. I'll show you where it is in a little while. All right, so factorial. Okay, so look at this right here. You see that this is 4. What's the next one? 3. What's the next one? 2. What's the next one? 1, right? So if I go from here to here, that decreases by what? 1. Y'all agree? Then from here to here, doesn't 3 decrease by 1 to get 2, and then 2 decrease by 1 to get 1, right? Okay, so the same thing here, 3 and then 2, 1. All right, so notice that the factorial, and then I'll give you the notation in a little while, but the factorial, this, if n is 4, then how do I get 3? I get 3 by saying 4 minus 1, which is 3, and I get 2 by saying 4 minus 2, which is 2, and then 1. Okay, so this would be called n factorial. Okay, listen carefully. So n factorial, and factorial looks like an exclamation point. See this exclamation point? Exclamation point. So n factorial will be n times n minus 1 times n minus 2 times n minus 3 all the way to 1. And it's a product of all these factors. Hence in the word factorial is the word factor, right? So you see all these factors, n minus 1, n minus 2, and so on. So what that means is this. So if I had like 6 factorial, that would mean this. That would mean 6 times, and what's 6 minus 1? 5 times, and what's 6 minus 2? 4 times, and what's 6 minus 3? 3 times, and what's 6 minus 4? 2, and then finally 1. So if you notice that the factorial, whatever your factorial is, it's just that number and then all the whole numbers less than that, and then multiply together. All right, and so if you had, let's say, 10 factorial, what do you think that would be? That would be 10, what else? Times what? 9 times 8 all the way to what? 1. Very good. All the way to 1. So that's 5 times 4 times 3 times 2 times 1. So the last digit is always what number? 1. The last digit is always 1. Okay? So that's the definition of factorial, and that's going to be used when we talk about permutation some more. Okay? All right? So let's look at the next page. So the next page we have, oh, and by the way, by definition, okay, so, well, I'll come back to that. So let's talk about what 4 factorial is. 4 factorial. Will you agree that 4 factorial is 4 times 3 times 2 times 1? All right, multiply that out. What do you get? 4 times 3 is 12. 12 times 2 is 24, right? What is 3 factorial? Well, 3 factorial is 3 times 2 times 1, which is what? Product. 6. What is 6 factorial? Well, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Y'all agree? All right. So on your calculator, let's go ahead and multiply those digits out. Okay, so you get 6 times 5 times 4 times 3 times 2. And you don't have to put the 1 because all these factors multiplied by 1 is still all these. But y'all agree that's 720? Okay, now before we do the next one, let me go to show you on your calculator where the factorial would be. All right, so let's see. Okay, so do you see on your calculator where you see PRB right here? You see it? PRB, that means probability. So that's where your probability functions are. So if I just click that for a moment, if you just press it, you see what shows up? In PR, we're going to talk about that in a little while. In CR, and then there's your factorial symbol, right? Okay, and you see there's an arrow up here, right here. See that arrow? So if I go further with that, see if I press this arrow, you can get some other stuff. Okay, so you can get RAND, RNDI. You're not going to use any of that, and I think that's about all you can get. Okay, so this arrow right here First of all, you see where it's underlined? So right now I'm looking at this. So if I press the arrow here, see how this is now underlined? And so if I press this arrow here, I get the factorial, and there's still an arrow up here. So if I press this further, I get more things. But that's you're not going to use any of that. Okay, so I can't. All right, now what I want to do though is show you how to use this on your to get this. All right, so basically what you can do is this. All right, so let's clear this, and you're going to press 4. So I want to try to find 4 factorial, right? So you're going to press 4, then go to PRB right here. Go to PRB, and I want the factorial one. So I'm going to move the arrow until I get to it. See it? And then you press equal. Press enter. You see this? All right, and then press equal, and you get 24. Well, saw it? All right, so let's do it again. So basically, you're gonna do 4 first. Press 4. Press 4. Okay. Then what else do I press? Where do I go next? You go to probability, PRB. All right. I want the factorial, right? So move your arrow. Move the arrow until it underlines it. Then what do? I press equal. All right. So I'm looking at 4 factorial now. I want to know what it is equal to. So I press equal. I get 24. All right. Let's do 3 factorial. Do the same thing. 3 factorial, PRB, move, go, underline factorial, press equal, you get 6. All right, 6 factorial, do the same thing, press equal, 6 factorial, 720. All right, now I want to go to that 0 factorial right here. So if I press 0 factorial, okay, 0 factorial, I get what number? 1. So by definition, 0 factorial is defined to be 1. Okay, see, you can easily see this part. You can see why 4 factorial is 24, couldn't you? Because 4 factorial means 4 times 3 times 2 times 1, right? You can see why 3 factorial is 6, because 3 factorial means 3 times 2 times 1. You could see why 6 factorial is 720, because 6 factorial means 6 times 5 times 4 times 3 times 2 times 1, right? And then it's a little bit more difficult, though, to see why 0 factorial is 1. Why is 0 factorial 1? All right? Because if you think about it, what's 1 factorial? Well, 1 factorial is 1. So is 0 factorial. 0 factorial is also defined to be 1. Okay? All right. So 1 factorial is 1, 0 factorial is 1. By definition, 0 factorial is defined to be 1. That's how we define 0 factorial to be. Okay? All right, let's look at 5 factorial divided by 3 factorial without using the calculator. All right, because I want you to see something. All right, 5 factorial means 5 times 4 times 3 times 2 times 1. Y'all agree? 3 factorial means 3 times 2 times 1. So if I reduce, see how I can reduce all these? I'm left with, in the numerator, 5 times 4, right? And the denominator is all 1, so that all that just becomes 5 times 4. Y'all agree? So what's 5 times 4? 20. So that's equal to 20. So 5 factorial means 5 times 4 times 3 times 2 times 1. 3 factorial means 3 times 2 times 1. If I reduce, I get 5 times 4 is 20. Okay? All right, and then I can use my calculator. So you'd say 5 factorial, probability, go to your factorial, press equal, divide by, do the division first, 3 factorial, same thing, and then press equal, and you get 20. And then what we got here? 20. Okay? All right, so let's look at some other ideas. Okay, so now at this time, I want to continue looking at some factorial problems. All right, so some factorial problems. I'm going to use our calculator at some point as well. But just as review to end what we're about to do, let's remind ourselves a couple of things. So first of all, 1 factorial is equal to 1. 2 factorial means 2 times 1, which is 2. 3 factorial means 3 times 2 times 1, which is 6. 4 factorial means 4 times 3 times 2 times 1, which is 24. 5 factorial means 5 times 4 times 3 times 2 times 1. And before I go on, let me just show you. Do you see that I can write 5 factorial as 5 times 4 factorial? Y'all see that? That's going to be important in a little while, but do y'all see that? So 5 factorial is 5 times, and then what is 4 times 3 times 2 times 1? Well, that's just 4 factorial, isn't it? And that's equal to 120. And using that same idea, what if I had 6 factorial? Do y'all agree that 6 factorial is 6 times 5 times 4 times 3 times 2 times 1? And if I wanted to, do y'all agree I can write this as 6 times, and then that is 5 factorial? Or if I wanted to, I want you to look at this. Couldn't I also write it like this? Couldn't I say that 6 times 5 times 4 factorial if I wanted to? Because 4 times 3 times 2 times 1 means 4 factorial. Right here, 3 times 2 times 1 is 3 factorial. So a bunch of ways I can write these factorials. Okay? 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1 in it. And again, if I wanted to, I could say 7 times 6 times, and then what is this I have on the line? And that 5 factorial? Now, at this point, I want you to use your calculator and just a quick review to see if you can remember how to find 7 factorial. So on your calculator, so remember how to do this. You're going to press 7 first. You press 7 first, right here. And then you go to probability, P or B. And then you press your arrow right here to get to underline the factorial. And then you press equal. And so you see 7 factorial, press equal, and you get 5,040. 5,040. Okay? All right, now, here's some examples I want to work out with you before we end this lesson. And remember, this is part 1 only. Okay, suppose I have this. Suppose I have, we're going to have to find each of the following. Okay, usually we're going to use a calculator if we need to, but I want to do this first without the calculator. Okay, part A. Suppose I had 9 factorial divided by, let's say, 7 factorial. Okay, 9 factorial divided by 7 factorial. Let's talk about this for a moment. Do y'all agree that 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1? And do y'all agree that 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1? Yeah, right, okay. But look at this. Why do all of this? See this right here? Any factor divided by itself, do y'all agree that's all ones? Right? That's all ones. Y'all agree? All ones. So really this is just 9 times 8, right? Which is 9 times 8 is 72. Okay? But what I want you to notice is this. You don't have to write all this out. Don't write all that out. All you had to do was this. I want you to use this idea that we did a while ago. I want you to know this. 9 factorial divided by 7 factorial is this. 9 times 8 times 7. Now listen, stop now, because this is 7 factorial, right? Well, in the rest of this, 7 times 6 times 5 times 4, 7 factorial divided by 7 factorial. And what happens to any factor divided by itself? Well, when I reduce, that is just 1. And so you get 9 times 8, right? Which is 72. Okay, part B. Suppose I had 73 factorial divided by, let's say, 69 factorial. All right, 73 factorial divided by 69 factorial. Would you really want to say 73 times 72 times 71 times 70 times 70, 69, and so on? all the way to 1? No, you don't. You want to use this idea that up to a certain point, the rest of these factors would be a factorial. And so 73 factorial would be 73. Tell me when to stop. 72 times 71. Do I stop there? Nope. I got to keep on going because I need a 69 factorial up here. So times 70, and then I can say what? 69 factorial, because the rest of this 69 times 68 times 67 all the way to 1 is 69 factorial divided by 69 factorial, and these divide out. And so you're left with 73 times 72 times 71 times 70, and then let's see what that is on your calculator. So 73 times 72 times 71 times 70 gives us big number. All right, so it gives us that number, about 26 million. Okay. All right, so keep that in mind. Make things easy on yourself. Okay. Also, I want you to do this. So you saw we did it this way. I also want you to use your calculator instead. Use the calculator. So if I use the calculator, remember how to do that? So you're going to say 73 factorial. So 73 probability. We need the factorial. Press equal. All right, then what else do I do? Do you remember? You press divide. Then you say 69. So it's divide by 69. Do the process all over again. Probability, factorial, and there you go. You see 73 factorial divided by 69 factorial. What do I do next? Press equal. You're right. And there we go. That same number, that right here. Okay? All right, so just also remember that 0, I didn't mention this here, but 0 factorial by definition is equal to 1. Okay? And remember the notation for n factorial is n times n minus 1. What's the next one? N minus 2. Yep. And what's the next one? N minus 3. N minus 4. Dot, dot, dot. All the way to 1. Okay? All right. So now you see all that here. All this idea is listed here. 3 times 2 times 1. 4 times 3 times 2 times 1. And so on. Okay? All right. So that's going to take care of part 1 of this lesson. And in part 2, we're going to look at the permutation formula. So we're going to look at this in part 2. You say, whoa, what is this? It's not that difficult. It's fairly easy to understand. So we're going to look at this permutation formula in a little while. Okay, so that'll be in part 2. All right, so that takes care of part 1.